Uh, all right, let's start off. Welcome, guys. This is a demo session for cloud computing on AWS. So, in this demo, we are going to look at a bit of what we're going to cover in the actual course. So, in this demo, we'll briefly talk about what is cloud computing and what is AWS doing in cloud computing, and then we will do a brief overview of what's that we are going to cover in the course, and then we'll understand what are the main reasons why you should go for the course with Collabra. Right. So with that said, let's start off. First of all, welcome to the session, and we are going to talk about cloud computing with AWS now. And before understanding AWS and cloud, what is AWS doing in cloud computing, the first thing that we need to understand is what is cloud computing at all, right? So many people have many definitions for cloud computing. It's almost like everybody has their own definition for cloud computing. Sometimes it appears that as if there is no standard definition for cloud computing, but there are some standard definitions also. If you ever go to wiki and type in what is cloud computing, this is what you get. This is what you get. So what does it say? It says cloud computing is a delivery of computing as a service rather than as a product, right? Rather than a product, whereby shared resources, software, and information are provided to customers and other devices as utility, like electricity grid over a network. So what is this typically saying is? It's saying cloud computing is delivery of computing as a service. So that is a crucial thing. Is there is something very crucial wordings here. If you carefully notice here, computing as a service rather than a product. Right. So what does that mean? That means here, if you need a server, you don't need to buy a server. Normally, in a normal world, what you do? If you need a server, or if you need a laptop, or if you need a database, what you're going to do is you're going to buy a hardware and then install the required softwares on it. So basically what you're doing is you are buying a product. But in cloud computing, what you're going to do is you're not going to buy a product. You're going to buy a service. That is what it says. Delivery of computing as a service rather than a product. So this line is very, very important. That is the gist of what cloud computing is. Here it is, this definition says only computing, but it's not just compute resources, right? You have other resources other than just the compute resources. You have other resources like database as a service, platform as a service, software as a service. All of these resources can be given to an end customer as a service, not as a product. Okay, so that this line is very important in here, and it goes on saying whereby shared resources, software, and information as provided to customers and others as a utility over a network. Right? What is saying is cloud computing is delivery of computing. Basically, any service, any computing service will be delivered to a customer as a service, not as a product. And in the earlier olden days, everything that you want, you buy a server, you buy the software, you install the software, then you run the application. Everything was being taken care by the end customer itself. But now, with the emergence of cloud computing, there are people who are specialized in delivering a product as a service, right? So here the important thing here is any computing service can be provided as a service, right? So the service provider is going to pool a bunch of resources, right? So if I'm the service provider and if I have hundreds of customers who need Linux services, then I might run 10 physical machines and create 100 virtual machines on them, and create 100 virtual machines to certain different customers. Here what I'm doing, I'm pooling a bunch of resources to give a service, right? The typical example in a real life example could be something like, say, everybody needs electricity. Everybody needs electricity, right? So if we need electricity, we are not going to set up a power plant in our backyard, right? We're not going to set up a power plant just because we need an electricity. We're not going to set up a power plant. So what are we going to do? There are people who are already specialized in electricity production. So what did they have done? They have already set up their electricity power plants. So what are we doing? We are just tapping into their grid. So there are power cables flying everywhere. So we're just using another cable from our home to that grid to tap into the power that is already being produced by electricity providers at their power plants. In a similar way, if I need a Linux service, somebody is already producing Linux service. So what do I need to do? I just need to use my internet to use those Linux servers. So that is what this definition is saying you, right? And then the second definition is by something called as NIST. NIST is like a standard. NIST is like a standard organization. So basically, NIST means National Institute of Standards and Technology. So they have come up with some very good definitions for what is cloud computing and what are the factors that make cloud computing a service and all of this stuff. So NIST is normally considered as a standard definition. So what does this definition say? Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resource. Example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So what is this definition is basically saying is cloud computing is basically a model where a service provider will provide you access to a pool of shared resources, right? There are shared resources and which are being hosted by the cloud service provider. So what is happening here is there will be end customer who's going to access the shared pool of resources using a network, typically an internet, if it has a public cloud, and if it has a local cloud or a local cloud, then it has a private cloud, then it is typically through internal network. So what is happening here is there is a bunch of resources, a shared pool of resources being hosted by a cloud service provider, and the end customer can use those resources, and also those resources should be usable in such a way that they can be rapidly provisioned. So tonight I need 100 Linux service, I should be able to get it. Tonight I need 5 TB of storage space, I need to get it. Tonight I need to have 5 different databases created, I should be able to do it. So anything that you want, you should be able to do it on the fly immediately and rapidly provisioned and released. So what does that mean? I've done using this 100 Linux service now. In the next hour, I don't need this 100 Linux service. So I should be able to delete those servers with minimal management effort or service provider interaction. So all of these actions, provisioning, configuring, deleting, upgrading, all of these things should be done by the end customer itself, and that too should be the way the end customer is going to access these resources should be very easy, right? With minimal management effort or service provider interaction. Say if I need a Linux server or if I need a Windows server, it shouldn't be a case that where I ask a service provider to give me a Windows server. I should be able to do it on myself, and that should be easy and that should be fast. So basically what is cloud computing is? There is a cloud service provider out there who is giving you resources, a pool resources, and there is an end customer who is going to use those resources using a network link. And if that model has to be called as a cloud computing model, there are some characteristics this model should follow. Let's look at that in the next slide. So the next slide says what are the cloud characteristics. Anybody cannot say that they have a good cloud computing model. Only if a cloud service provider satisfies all of this characteristics, only then they can themselves called as a cloud service providers. Okay. So the first characteristic is on-demand self-service, right? On-demand self-service. So what is this meaning? What does it mean? If I being a customer, right? If there is a cloud service provider, and if I being an end customer, I want a Windows server. So I should not be asking or raising a ticket, you should typically hear the word raise a ticket. So I should not be asking someone or raising a ticket or calling up someone to get a Windows server or to get a Linux server. I should be able to do it myself through whatever the interface is. End customer should be able to do by himself on demand whenever I need, self-service whenever I need, whatever I need, I should be able to provision it. Okay, the next characteristic is broad network access, because most of these cloud service providers are going to be in a different geographical region, right? Probably in the same city, but they are in a different geographical region. So all of these services will be accessed over a network. If the connecting pipe or the network link is slow, all of the other services will look as if they are running slow. So any cloud service provider should have a broad network access, right? And resource pooling. The third important characteristic is resource pooling. So as we discussed earlier also, so a cloud service provider is going to pool a bunch of resource, right? So for example, a cloud service provider has bought 1,000 physical servers. He may create 5,000 virtual machines on top of those 1,000 physical servers, and these 5,000 virtual machines can be given to multiple customers. So the end customer will not even know on which physical machine his virtual machine is running, right? So all of these resources will be pooled together to give end customers the required resources. Then the next characteristic is rapid elasticity. So this is very important. You would have seen, say, for example, if there is a news event, for example, there are some exit polls tomorrow. So what's going to happen if, let's take a typical example of a news site, and they are doing some exit polls today or tomorrow, whatever the day is. So normal capacity on a normal day, probably only 1,000 users visit their site to view the live news. But on a exit poll day, probably there could be 10,000 people logging into the site to see the election results. So here, what's going to happen? The demand for services, the demand for the number of servers goes up very fast. So my cloud model should be in a position to provide those services. So rapid elasticity. So while the exit polls were running, there were 10,000 customers who were accessing my say 100 servers. But after the exit polls are done, again my load will come down to normal. My load will again come down to normal. The next day, again, I'll have only 1,000 customers, which can be served by only 10 servers. So as of my capacity has gone from 10 to 1,000 servers, again it should come back from 100 to 10 servers, so that I can save money. If I'm going to run those 100 servers, I'll have to pay the cloud service providers money for running those 100 servers. So my cloud service provider should be in such a way that whenever I need a bunch of services, in this example servers, I should be able to rapidly provision it and rapidly delete them, rapidly provision it and rapidly release them. So I should be able to do both of these things. Only then it is called as elasticity. Okay? Elasticity is not just about growing. Elasticity is also about coming down, right? Cutting down, whatever it is, whatever you want to call it, right? Then another important characteristics of a cloud model is measured service, right? Say I want to use a storage. I want to use say 1 TB storage from a cloud service provider. I have to clearly understand how much storage I'm using, right? It is not every service that we are going to get is from another service provider in cloud computing model. So all of the services that are being provided to you should be properly measured. For example, your telephone bill. Say probably if you go for a postpaid connection, by the end of the month, they will clearly tell you how much you have, how many minutes you have spent talking to, and how many messages you have sent, how many ISD calls you made, how much data you consumed. So everything is measured. In a similar way, if I'm a cloud service provider, providing compute service, providing database service, providing storage service, providing network service, in this way, say I'm providing 10 different services. So all of the bills that I'm going to get should be clearly measured. That means how much I have used for storage, how much I have used computing service. So every service that I'm going to use should be properly measured. Okay, these are the five very important characteristics of cloud computing. Any cloud computing model should satisfy this characteristics, only then it can be called as a cloud computing model. All right, now let's move a bit forward, and in the slide we will look at what are our cloud service models. You guys would have already heard about, everybody talks about software as a service, platform as a service, infrastructure as a service. These sound like a fancy words, but they are not actually. They are simple terminology with respect to cloud computing. Say for example, if I have an application that I'm running on premise, I'm the customer and I'm running an application on premise. So I have set up the service, I have configured the storage, servers, virtualization, network, everything that I have done. Everything, all the layers that go into making an application, everything that I have done. Right? This is something like a on-premise model. But I have another model. I have a couple of other models like platform as a service, infrastructure as a service. So if I go for something like a infrastructure as a service, like if I'm talking about something like an infrastructure as a service, in infrastructure as a service, what's going to happen is I'm the end customer. This is me. You is me here. So if I'm the end customer, all of the infrastructure for me will be managed by someone else, some other cloud service provider. So what they're going to manage for me? They're going to manage the virtualization layer, the servers, the storage, networking. So all of these components will be managed by my cloud service provider. So if I need 100 servers tonight, I don't need to buy 100 physical servers. Right? I don't care how my infrastructure service provider is going to get me the service. All I need is I need 100 servers. How they are racking it, how they are stacking it, how they are going to provide AC, how they're going to cable the servers, what is the operating system they're going to install. All that headache will be taken care by the service provider. Here, in our case, it's an infrastructure as a service provider. And there is another type of service called as platform as a service. And platform as a service, what you're going to get is the end customer. The end customer is going to, that is me in this case. I'm going to manage only the application and data. So, say for example, if I have to write a Java program, I'm an end user. I want to write a Java program. I just want to write a Java program. I don't care about whether the Java compiler is installed, how it is installed, what are the required software. In those cases, everything with that, right from the Java compiler to all the way up to networking, hardware, virtualization, everything will be taken care by the service provider, right? And then there is other model called as software as a service. So for example, I just need to use a software. I don't want to install it. For example, Google Docs, Google Excel, Google Word. You would have used it, or else Google Gmail. For using Gmail, what are you installing anything on your machine? No, you just need a browser to access the software. Somebody else has written a software, installed it, they're running on the physical machines, everything they have taken care of. What we are doing is just using that software as a service, right? That is something like a software as a service. You guys have any questions? Any questions, guys?
Yes, sir, I have a question. Can you please give me an example of a service in AWS for infrastructure as a service and a platform as a service, please?
Okay. AWS is a bunch of services. AWS has many services. Just for your knowledge, I can say that at this moment, EC2 is an example, which is called as Elastic Compute Cloud, which we are going to talk about in the class, is a infrastructure as a service. right? And then you have other platforms or services like something like probably something like Elastic Beanstalk is a platform as a service. Here, all the underlying infrastructure will be taken care by AWS, and all the runtime, middleware, operating system will also be taken care by the AWS. All you have to do is you have to take your application and run the application. That is something like a platform as a service. Okay. Right. So let's go forward. Okay. And even in you would have heard about it. People talking about public cloud, private cloud, hybrid cloud. Okay. So you keep hearing these terms. People talk about I have a public cloud or we have a private cloud environment. So what does that mean by a public cloud? What does it mean by a private cloud? What does it mean by hybrid cloud? Basically, a public cloud is a cloud which is open to anybody in the world. Right? Public cloud is a cloud which is open to anybody in the world. So what does that mean? Like say for example, AWS is a public cloud infrastructure. AWS is a public cloud infrastructure. So what does that mean is anybody in the world can use AWS to run whatever the services they want to run. Either it could be a compute service, database service, depending on what service they want to run. Anybody in the world can use AWS. That is something like a public cloud. A public cloud is a cloud service which is open to internet. Okay? It may be accessed by anyone. Then you have something called as a private cloud. Right? Private cloud is a cloud infrastructure in which the cloud infrastructure is internal to an organization. Say I'm working for Collabora. We are going to set up a cloud environment, but we are going to set up a cloud environment to be used only by Collabora, not by anybody else outside the world, not by anybody else outside Collabora, right? So that becomes a private cloud. Private cloud has boundaries. Private cloud has boundaries which is only internal to the organization. Okay, and generally private clouds are owned and managed by whatever the organization who is going to set up it. Right? In public cloud, so for example, AWS is owned and managed by AWS, Amazon. But in private cloud, if I'm setting up a private cloud environment for Collabora, the cloud is owned and managed by Collabora, and even that is only internal to Collabora. Okay, that is something like a private cloud. Then you have something else called as a hybrid cloud. This hybrid cloud infrastructure is like a combination of a public and a private cloud. So what's going to happen in a hybrid cloud is, say I might have an application for which I need to run 3 servers in my private cloud and 2 servers in my public cloud. Then what I'm doing is I'm building the solution using my private cloud and my public cloud. So that becomes a hybrid cloud. When you build a solution, when you build an infrastructure using components from your private and public cloud, that becomes a hybrid cloud. Okay. Any questions, guys?
Hello. Can you please give other example of a service in public cloud?
Other examples of services in public cloud or something like Microsoft Azure, Google Compute Engine, and then there is Rackspace. So these are all other public cloud service providers other than AWS. AWS, we are going to look at it. That is what we look at in the course. But other than this, there are other players. Even those other players, the market survey says that when you compare AWS with other public cloud service providers, the next 5 public cloud service providers altogether are not equivalent to AWS at this moment. So AWS has a huge lead in public cloud. So that's the reason you see all the jobs on AWS. Okay, and there's a good time to get into AWS for sure, because there are not many people know about AWS, and there's a huge requirement for AWS. All right, so let's go forward. What are the cloud computing benefits? So why should you go for cloud computing at all? Why should you go for cloud computing at all? One of the most important benefits is dynamic scaling. Dynamic scaling. So this is important. As I said, exit polls, you are a news company. Normally, there are only 100 people accessing your news company's website during a normal day. But on an exit poll day, probably there are 10,000 people accessing your website. 100 versus 10,000 people. That is a huge increase. So for customers to access your website, your web service should grow probably in the count. So normally for 10 people accessing my service, 100 people for accessing my service, I need 10 servers. But when 1,000 or 10,000 people are going to access my website, I may need more number of servers, right? I may need more number of servers. So with cloud, I can configure my applications in such a way that whenever there is a load coming into my website, my service will automatically grow, probably in the count. Instead of 10 servers, I'll configure it in such a way that I can get 100 servers within fraction of minutes, so that my website will not go down. If my website is not able to scale properly, say, as I said, 100 to 10,000 customers have grown within a matter of, say, 2 hours. If I don't have enough cloud resources, enough computing resources, my website might go down, which is not a good thing. So with cloud computing, you get something called as dynamic scaling. Then you also get shared resources. As you're going to share resources, the cost of the resources is going to come down. And then another benefit is pay as you go model. Normally, say if you need a Linux server or a Windows server, or if you need a server at all. So typically, a enterprise class server is going to cost you $10,000. In the current market, typical enterprise server is going to cost you $10,000. So I'm a small company. I'm a very small company. I'm just starting up. I know that I'll need 10 servers, but all that I have is only $100,000 or $1 lakh. I just have $1 lakh. I'm starting a new company. I know that how to set up my business, how to run my business, I know it. But I need 10 servers for it. If all the money that I have is only $100,000 or $1 lakh. So if I'm going to buy those 10 servers upfront, if I'm going to buy those 10 servers right now, what's going to happen? All the investment that I have, I'm going to spend it on buying the servers. So what do I do with, how do I get more investment for other purposes, right? I'll not have any investment. So with cloud computing, what you get is something called as pay as you go model. So you don't buy anything. You use 10 servers for a month, you pay probably only 1/10 of it, right? So it is like a monthly charge. Pay as you go model is as on when you need, you're going to use it and you're going to pay for it, right? And then increased mobility, right? Say for example, I have my website, I have a successful website running in US. Now I'm planning to start another website in India tomorrow. I want to start another website in India tomorrow at any cost. So if I want to do that, if I don't have cloud, so I have to set up a new data center in India, then bring up the servers there, copy the data from my US data center, bring up the site. So this is all going to take a very long time. But with cloud computing, you can start up probably a data center in cloud within matter of minutes. So you have a lot of mobility. Less or no capex. As we talked about the pay-as-you-go model, you will not have any, or even if you have any capital expenditure, which will be very, very less. High availability. Cloud computing has this feature of called as high availability. Especially with AWS, you can achieve high availability levels up to geographical locations. So what does that mean? Say I can say if I'm running a website, if I'm running collabra.com website, I can have one of the server in say in Singapore, another server for collabra.com in US. just in case if something wrong happens in either in US or Singapore, two different geographical regions. One is in Asia, another one is in US, right, North America. Even if one of the continent goes down for some reason, right, for some reason one of the continent itself goes down, even then my website will not go down because I have two servers working as highly available servers. I can do that in AWS. Easy to manage. All the AWS is easy to manage. You just have one console. It's like one pane of glass through which you can manage all the AWS resources. Okay. Then high productivity. So for a normal business, if you don't have to invest on IT, if you don't have to invest much time on IT, and you just want to do with your business, there's high productivity, environment friendly. As instead of running say 100 different data centers, if somebody is going to run one data center for all of those 100 customers, it is going to be very environment friendly with respect to the carbon emissions and the AC, power requirement, all of this stuff. Less deployment time. Here, with especially with cloud service providers, I don't have to wait very long to get a server. I don't have to very long wait for getting a storage. Okay, everything can be done within a matter of seconds. All right. Any questions?
Yeah, I have a question that is it really easy to manage AWS?
Yeah, it is. We are going to look at it. Probably, I'm just going to give a brief demo on how to create a machine. You'll see how easy it is, right? You'll see how easy it is. It's really easy. It's all everything you can do it from only one web page. So we're going to look at that. Okay. The next, so that is a brief about cloud computing. Now let's look at AWS, which is the main essence of this course. So in this course, we're going to concentrate on AWS. Okay. So with AWS, what you get is you get different services. You get different services like compute services like database service, services like storage services, networking services. These are all the services that are typically required to run an application, and even these services will be run from different places of the globe, right? So probably I can have, as I said, to create a highly available website, I can have one server running in US and another server running in Singapore or Australia, so that I can achieve something called as high availability. In a similar way, I can AWS provides you a bunch of services which are running in different parts of the globe. On top of this, you can run your application using any of the services that you're looking at, right? So AWS provides you all of these services. We're going to talk about most of the services in the class, may not be all, but we're going to cover most of the important services which are being used in the market. Okay. Any questions?
Yeah, do I have to use all the AWS services to run applications?
You don't have to use all the services. It is all down to what is the service that you want to use. If I just want to run a database, I don't have to use a compute service. I don't have to use a storage service. I can just run a database service. Okay. All right. So let's go forward. So basically, AWS computing platform. This is something like a representation of this diagram, but in a much meaningful way. As I said, AWS has something called as a global infrastructure. So what does that mean is, AWS have data centers spread across the world. So these data centers are going to run servers, networking, databases, all of these things. This global infrastructure is going to run. And currently AWS has data centers in all the geographical locations. Like they have data centers in North America, they have data centers in South America, they have data centers in Europe, Asia, Australia. So they have data centers in multiple places. So all they run different services like foundation services. They run compute service, they run storage service, they run database service. Compute service is basically a service through which you're going to get service. Storage service is basically a service through which you're going to get storage space. I want to store 1 TB of file. I want to store 10 TB of files. Then I'm going to use a storage service. I just want to run a database. Then probably I'm going to use a database service. Then you have networking services. Then you have content distribution services. Then you have one place to manage all the access, that is called as administrative console. And you want to create users for AWS, that is something called as identity access management. Then you have something called as a monitoring service. Say you provision 5 EC2 instances, I want to monitor the CPU usage of those instances. Then you're going to use something like monitoring services. Okay, so AWS has multiple services. So AWS, these are some of the core AWS services when comparing with the traditional infrastructure. Normally, when you create a service in AWS, they are called as EC2 instances. In a normal world, you create different kinds of storages like DAS storage, NAS storage, SAN storage. Different words for them are Glacier storage, which is a tape-based storage. Then you have a block storage, similar to your SAN storage. Then you have a S3 storage, which is a object storage. Then in a normal world, you have something called as RDBMS. And here it is called as relational database service. So AWS have a bunch of services which are very similar to your traditional infrastructure services, but they are called with the different names and they are very powerful. Okay. All right. So some of the AWS keywords are on demand. So what does this on demand means? Whenever you need a service, you're going to get it. And uniform. So whatever data center that you're going to choose with AWS, right? Everywhere you're going to get the same services. It doesn't mean that, say, if I'm going to provision a server in US, it's going to be faster. If I'm going to provision a server in Singapore, it's going to be slower. It's not like that. Wherever you provision, you're going to get it. The performance is going to be absolutely same. Pay as you go. With AWS, you don't have to buy anything upfront. So everything pay as you go. So as much as you use, you pay for it. Okay. Then available. Everything is highly available. AWS is designed keeping in mind that everything can go bad, everything can fail. That is the core designing principle for AWS. So with AWS, you can design infrastructures which are very highly available. Okay. All right, so let's go forward. So in the course, what we're going to do is we're going to talk about cloud computing. Then we're going to look at a bit of virtualization, a brief discussion about virtualization, because most of the cloud computing depends on virtualization. Right? So we're going to talk about virtualization. Then we're going to talk about AWS. Then we're going to talk about a compute service called as Elastic Compute Cloud, right? EC2. You would have heard about it, Elastic Compute Cloud. Then we're going to talk about something called as a storage service called as EBS storage. Then we're going to talk about a very important service and very interesting service called as autoscaling. All right, any questions?
Hello.
Yeah.
Yeah, so just had this question. Can a EBS volume be connected to two EC2 instances?
No. A EBS volume can be connected to only one EC2 instance. If you want to do a shared storage, you can do it, but that is using different methodologies, which we are going to talk about in the course. Right? The actual course, we are going to talk about it. Then going forward with the course outline, then we're going to talk about other services called as simple storage service, which is a object storage. Say you want to upload, download file, something like a Google Drive. You want to upload, download files from anywhere across the internet. You can use a storage called as simple storage service. Then you have the storage called as Glacier storage. You want to store data on tapes, because people store data on tapes because tape storage is cheaper and much reliable. You want to store data for 10 years. Then probably you want to use the better solution for you to store data is tape storage. So AWS has a tape storage that is called as a Glacier storage. Then you have a content distribution service, something called as CloudFront. Then you have a service called as identity access management. In the identity access management service, you're going to create users, you're going to create groups, you're going to set policies. All of this being done in identity access management. Then we are going to talk about something called as Route 53. In Route 53, you can host websites. Say for example, if I type www.collabra.in or collabra.com, it has to go to a specific EC2 instance. So all of these definitions will be defined in Route 53. Then we are going to get into a bit of advanced topics, something called as virtual private clouds. Even in the public cloud infrastructure, you can create your own private cloud, private networks. That is called as a virtual private cloud. Then you can. Then we're going to talk about something called as a relational database service. Say if I want a Oracle database server or a MySQL database server, then I can use relational database service. I don't need to install Oracle database. Sometimes installing Oracle database itself is going to take a couple of days for me. Instead of that, if I'm going to use RDS, it's a matter of minutes. Okay. Then we're going to talk about something called as CloudWatch, which is a monitoring solution for AWS. So we're going to talk about it. Then we're going to talk about other services called as simple notification service. Say if I have a machine, or if I have a storage space and the storage space is at 90%, I want to get a SMS saying that storage usage is at 90%. So if you want to get an SMS, then SNS is going to help. It is going to notify. Then we have something called as Elastic Beanstalk, which is a widely used service. People host their applications on Elastic Beanstalk, so we want to look at that. Then we're going to look at CloudTrail. I want to monitor who is accessing my AWS console. So that all can be done in CloudTrail. Then we are going to do a brief overview on what all AWS certifications we have and how can you get prepared for that. Okay. Then we are going to talk about cost control tips. Many of the people move to AWS just to save costs. And how to save cost, I'm going to give you some tips on how to save costs in an AWS infrastructure. Then we are going to install a multi-tier application. So if we are going to have some web servers, some database servers, we are going to do a small multi-tier application on top of AWS by implementing what we have learned throughout the course. Okay, so that's a brief overview of what we are going to talk about in the course. And let's talk about why you should take a Collabra TACT course. Basically, TACT is Technology Advanced Academy for Competency Training. It's a new initiative started by Collabra. Basically, Collabra is a $550 million company, and we have a lot of employees placed everywhere in the globe. So, especially with Collabra, what you're going to get is you're going to get some quality training, and the presence of Collabra is across the world, right? Collabra has a lot of branches in US, a lot of branches in India. Collabra basically it's a global IT staffing company, if you don't know about Collabra, and we are focusing on training requirements. So at this moment, we are also doing upskilling talent and providing relevant employment opportunities for our students. Then 75% of our clients rank us in their top 3 suppliers by performance. So there are a lot of companies which are looking out for people, and 75% of our clients, which are the companies, rate as top 3 suppliers. Right, so we do get people, hire people, and supply them to the companies. Then we have recently started giving trainings from Collabra, and at this moment we have more than 10 courses that are on offer by. If you go to TACT site, you'll be able to get information on that. So let's go forward. Collabra TACT is an immersive training program that aims to provide modules on the most sought after emerging IT technologies and engineering design tools. So we are doing some very interesting training programs, which are really the requirement for these training programs are huge in the market. And so we have picked up some of those technologies which have really high demand in the market, and we are conducting training programs for that. And with Collabra, what you get is once you enroll for the course, you have something called as a LMS site, right? Which is a learning management site. So here you're going to get a 24/7 access to your LMS site, and all the videos that we're going to talk about in the course will be uploaded in the LMS site, and all the say assignments, exercises, project work, everything will be uploaded into the LMS site. You can access it from anywhere in the world. Okay. So we are doing a strong focus on core concepts and industry practice content. So we develop our content going through a lot of iterations, and most of our faculties are industry working professionals with years of experience, and our training infrastructure is seamless and very good. Some of the other key benefits are you have high quality experience, state of the art infrastructure, and lifetime access to your 24/7 LMS site. Right? As I said, whenever you want to access a video, say if you have missed a class, if you have subscribed for AWS class and you could not attend a class for some reason, you don't have to worry about it. All the videos, all the sessions are uploaded to the LMS site. Once you enroll for the site, once you enroll for the training, you're going to get access to the site, and all the videos are there. You can watch it at your own convenience. You don't miss anything as such. So you also can track your progress on the course. You also can get notifications whenever there are new assignments are created, or you can also we also have forums where you can post your queries. You can also have a customized dashboard. Okay. So once you have access to LMS, these all things will come into play, and these all things are very interesting. Other than the AWS, we are also offering other courses like Big Data Hadoop Developer, then Big Data Hadoop Administrator. Then we also have Cloud Computing with AWS. Then other courses that we offer are like Storm, Python Programming, Mastering Python, Analytics with R. Then you have Android Development, Java Programming, Linux Administration. Then you have Digital Marketing, PMP. If you're looking for PMP, PMP is one of the class conducted by Collabra. Then you have a soft skills program. Probably if you're a fresher, or if you doubt about your soft skills, then probably you should enroll into your soft skills program. So those are all some of the other training programs that are being conducted by Collabra at this moment. There are some new courses also coming up. Probably you should go to collabra.com and check for the newer courses. So with that said, basically what Collabra has is some 350 plus clients across the globe. So we Collabra know what is the requirement in the market, and we are trying to train people, help them getting jobs in those 350 clients and other places. So we have a lot of industry knowledge as to what's happening, what is the current IT trend, where are the clients looking for. So basically we concentrate on what is the client requirement and how you as a student can meet those requirements. So with that, you should be in a good place to find a new and exciting career. Okay. All right. So with that said, I'll show you a small demo on how to create a EC2 instance. So we are going to open up aws.amazon.com. We are going to talk about what is aws.amazon.com, how do you create an account, how do you sign up for AWS console, all of those things we are going to look at it. I'll also help you to create a AWS account. This is basically the EC2. This is basically the AWS console. There is one place through which you are going to manage all the resources of AWS. Right now, what we are going to do is we are going to create a Windows server. Right now, what we're going to do is we're going to create a Windows server. So what we're going to do is we're going to click on Launch Instance. This is basically going to ask you what is the operating system that you want to run. I want to run Windows operating system, right? So I have a bunch of Windows operating system selections here. I want to run a Windows Server 2008 R2 base. So I'm going to select it, and then I'm going to, so what is the memory that I need? What is the CPU that I need? Probably I need one CPU and 1 GB of RAM. I'm fine with it. Then there are a bunch of settings here, and there are a bunch of settings here. We are going to talk about each of these settings in the class, like what is an IP address you want, what is the monitoring frequency you want, how many instances you want, what is the pricing mechanism you want. These are all things we're going to talk about in the course. For now, I'm just going to go to the next screen, leaving everything default. Add storage. So I'm going to get a how much storage you want to give to the EC2 instance, the Windows machine that you're going to launch. We are going to use 30 GB for the storage. Then tag instances. We are going to talk about tagging of the instances. How do you create security groups? These are basically something like a firewalls for your EC2 instances. We're going to talk about this in the course. Click on review and launch, then click on launch. So every machine that you're going to launch will be associated with a key pair. You're going to talk about what is this key pairs, how do you use these key pairs to secure your machines, how do you use these key pairs to log into machines. We're going to talk about all of these things during the class. Now if I go back to my screen, I see that this is a machine that I have launched earlier, but I see that there's a new machine coming up. A T2.micro instance, a Windows machine is coming up. So once this machine comes up, I should be able to log in. Typically, a Windows machine normally takes 3 to 4 minutes to be coming into the running state. Running state is a state which generally means the machine is running and you should be able to log in. This is typically going to take, as I said, 3 to 4 minutes. So this machine is running. I can click on connect. I'm going to download the remote desktop file. Right, it has downloaded a remote desktop file. Now I can click on connect. The machine is completely booted up. It's going to take me to the login prompt. It might take a couple of minutes for the machine to come up. Machine is still coming up. Download remote desktop file. Once I click this, because this is a Windows machine, obviously it's going to take a bit longer time to boot. I think the booting is in progress. And once this machine comes up, we'll have to log in as a administrator. For this, we'll have to get the administrator password, for which I'll have to click on this button and I'll have to give a key file which we have used to launch the Windows machine. But for that, we'll have to wait at least 4 minutes after you launch the instance. The instance is coming up. There are a lot of things in the AWS console that what we're going to talk about. We're going to talk about EC2, we're going to talk about Elastic Beanstalk, then we're going to talk about S3, CloudFront, Glacier, RDS, DynamoDB, VPC, Route 53, Direct Connect, CloudWatch, CloudFormation, CloudTrail, Identity Access Management. Then we're going to talk about something called as Trusted Advisor. Then we're going to talk about something called as SQS, right? So these are the frequently used services on AWS platform. So we're going to talk about many of the things and many of the things in detail. Right? Let's see if our machine is ready to log in. Hope it's 4 minutes done. Let's try to connect to it. It's 4 minutes done, so it's asking for a file, and we'll see how to generate the file during the class. I have the file generated already, so it has asked me to give the file, so I gave the file. So now it has the root or the administrator password to log into the Windows machine. Now if I want to connect to it, I just have to click on connect. I can download the remote desktop file. Now I'm going to open this file and I'm going to log in as administrator and the password. So this is how easy it is to get a Windows server. And a normal build without AWS, right? If an organization typically needs a Windows server, it's going to take at least 3 months before getting a new server. Imagine they don't have any infrastructure set up. They want a new server. It might take anywhere between 3 to 6 months. Right? All right, guys. That's it for this demo. Have a good day ahead. All the best for you guys.